welcome everybody. Today in this video I'm going to be explaining how OSPF poisons a route. I've done a video on this before on OSPF and EIGRP, and after I did that video I was kind of confused because I've read many sources, many Cisco press books that say, oh, when OSPF needs to tell a neighbor about a network being down, it sets the max age timer of the LSA so it ages out. And I was like, okay, but I did a packet capture and that wasn't the case. So then I started questioning, where did they get that information from? What does that mean? So I emailed some people, read more books, and then I finally decided to do a lab on it, and I finally understood where that max age timeout of an LSA comes from. So what happens when a route goes down within an area? An updated LSA will be flooded with a higher sequence number, and it's going to not include that route. So let's say there was a loopback on router 1. When that loopback goes down, instead of setting his own LSA to the max age, because that's going to get rid of all routes for his neighbor, he just needs to tell R2 and R4 about that one specific route. He'll just reflood his that one LSA and not include it. So I got Wireshark going on, and that's what I'm going to capture. Now what happens when it goes from area 0 to area 1 on either side? Well, this is where the ABR comes into play, and for every route that is in area 0, that whatever router 4 and router 2 knows about, he's going to send out a separate LSA, a separate summary LSA to the next area. So in this case, either side is going to be area 1. So let's say let's say router 4 knows about 5 routes. He's going to make 5 LSAs, 5 type 3 LSAs, and inject it into area 1. And then when that specific loopback goes down on router 1, R4 is like, oh, okay, since I made a separate LSA for that loopback route, this is where I will set the max age timer for it, and then I'm also going to increase the metric to the OSPF's infinite metric, which is 2 to the 24th power minus 1. So that will actually age out, and R5 will get rid of that specific one, but still know about the links that are connected to R1. All right, let's view this first one, where R1 will just reflood an LSA with a higher sequence number. So let's go to R1 real quick, and we have to do some. Got to verify some things. So let's do a show IP OSPF database, and let's take a look at. Good. Okay, let's take a look at R1's LSA. So he has a sequence number of 5. Okay, and once we shut down the loopback of R1, this will be incremented, and then we'll also see what it says in Wireshark. I got Wireshark going on right now, so we'll take a look at that. Okay, let's also verify on router 2 that he has that same LSA. Sequence number of 5 from router 1. Good. All right. Oh, and this right here, this is in seconds. All right, so the age of this LSA at that point in time that I did that command, 179 seconds. Okay, all right, let's go. Let's do this. R1, config T, interface loopback 1, shut it down. Give it a second. All right, cool. Now it's down. Now let me go to router 2 real quick. Hit the up arrow. And it just incremented to 6. And now let's go into that Wireshark capture. There it is. And if we open it up, OSPF is only talking about 2 links for router 1, and it is 10.0.14.1 and 10.0.12.1. Alright, so that network, so the loopback that actually went down, I didn't even show you guys what that was. Do show IP interface brief, exclude unassign. The loopback that they knew about was 10.0.1.1, alright, and it was administratively shut down. If I do a no shut, and we look at this Wireshark update, it is there, alright, but notice that the sequence number was incremented, but we want to see it go down, which I already did. No shut again. Go back to Wireshark. As soon as it comes up, we should see an LS update. Did it come back up already? Oh, I'm supposed to shut it down. Yeah, see? There you go. Not in there. Cool. And we see that it's incremented. So, again, that proves that within an area, that's what happens. The LSA sequence number is incremented, and that route is not included. Now let's take a look at the Wireshark capture when we go to a different area. All right. So let me stop that. Let's slide on over to router 3 real quick. And let's do a show IP OSPF database. Well, that thing is, I need to bring it back up. No shut. Where's that link? There we go. That's that loopback I'm looking for. Notice that it is a summary LSA, and it is that's the loopback for that specific route. All right. And this is a brand new LSA, because now you see that the sequence number is 1, and also the age is 1 second. So I have 1, 2, 3, 4, 5 type 3 LSAs. If I do a show IP route, OSPF, I should probably have about 5 OIA routes. Let's take a look. And I do. See? So that's what this means when I look at the database. I have 5 external area routes, inter-area routes, right? Okay. All right. Now I'm going to do a shut on this, but let me capture this interface real quick. And what I'm expecting to see is that specific LSA is going to have the age increase to its max, which is 1 hour, which is about 3,600 seconds, I believe. Yeah, 3,600 seconds. And then the metric is going to be huge. So let me bring up Wireshark, and let me only look at OSPF stuff. And if I look at router 3 real quick, and I do a show IP OSPF database for the summary LSA of, who was the advertising router? No, I want to see this specific one, because this is that loopback. The metric is 11 right now. Okay, sequence number is 1, and the age is 81. Okay, let me shut down the loopback interface. Shut it down. OSPF should be sending an update. There it is. And if I open that up, the sequence number was increased. The age is to 3,600 seconds like I predicted. And then where's the metric? Metric is 16, oh my gosh, what is that, 16 million? 16,777,215. And that's where that whole 2 to the 24th minus 1 comes into play. So if I bring up my awesome calculator here, shrink it. 2 to the 24th equals that, minus 1. Yeah, there we go. So that's where that came in from. All right. Actually glad I'm doing this video, because there's tons of documentation that says, oh, this is the max metric, and like this is how OSPF, poisons a route. They don't specifically say for this area or for that area. And if I pull up the book that I'm talking about here, this is the CCNA book. This is the ICND 1. What book is this? Yeah, the ICND 2 book. Sorry, not 1. And in the CCNA book, it says OSPF version 2 uses route poisoning for failed routes. Yes, it does. But if I scroll down, what is its infinite metric, right? Well, it says 2 to 24 minus 1. Cool. That's awesome, but it doesn't really tell me how it's actually used. So this is where I put 2 and 2 together, and I'm capturing this, one with this recording and using Wireshark so we could all see it. So I hope that gave you a better understanding. Also, this whole concept of a split area, like area 1 is over here and area 1 is over here, that is okay in OSPF. You could have discontinuous areas just as long as you don't have a discontinuous or discontiguous area 0. Area 0 is the backbone and the transit area. So from OSPF's perspective, areas don't matter except for area 0, right? It's just because when you pass on updates, the area isn't part of the LSA, right? So yeah, so that's all I got for you. I hope this was informative, and I'd like to thank you for viewing. Got for you.